IoT Wireless Personal Area Networks, IoT WPANs, is what we will study now. The most popular modem spec is the IEEE 802.15.4 standard, and it is used for low cost, low speed. Low speed means low speed data rate, which means that the data rates are not going to be that high, and low power are the typical characteristics. Once again, this is a wireless PAN, wireless personal area network. That is why typically we're talking about low power is very important. IEEE 802.15.4 applications include Zigbee, 6LoWPAN, which is short for IPv6 over low power WPAN, wireless HART, where HART stands for Highway Accessible Remote Transducer, and also MIWI, Microchip Wireless Protocol, and also RF4CE, which is Radio Frequency for Consumer Electronics, as well as the ISA 100.11a. These device types typically are two, where we have a full functional device and a reduced function device. Typically, a full function device has full functionality. That's where it gets its name. It can send, receive, route data, and form clusters. It can serve as the PAN coordinator, meaning that for a personal area network, it is the coordinator node that manages, controls, access, and network overall connectivity. It is a critical component, feature, function that needs to be operated such that the network can expand in its overall multi-op connectivity. Reduced functional device has, of course, just reduced functional capabilities. Reduced as in terms that it doesn't have all of what the FFD will have. It can only communicate to FFDs and cannot serve as a PAN coordinator, serves the role of a simple sensor or switch, and it does not have functional routability. Networking topology-wise, you can have a star network, a peer-to-peer network, a mesh network. If you're going to use this, you need peer-to-peer extensions with full functional devices, and also one of the full functional devices need to be serving as a PAN coordinator. Then also cluster tree networks. Coordinator, this controls the IEEE 802.15.4 network. It is a special form of a full functional device, and typical FFD functions and network coordination and service features are added. Looking into some details of the network topologies. Star topology here, where the nodes communicate through the central PAN coordinator that is located in the middle. Now, the ones that have the blue color are the FFDs, and the ones that are just white are the reduced functional devices. The reduced function devices are just listed in white. And as you can see, this is what we have. Then we have P2P topology, where nodes can communicate through the PAN coordinator and through point-to-point links. Extensions of the star topology are enabled through the P2P topology. Over there, you can see, looking at the network topology above and below, you can see that there is an additional connection between a FFD and RFD. A full function device and a reduced function device are connected there at the bottom. So this is what this specification is talking about. In addition, cluster tree topology. If you're going to grow a network, if you have many IoT devices, then this is definitely what you need to use. And cluster tree topologies are very attractive, especially for wireless sensor networks and IoT networks that have a lot of nodes. In the world we're moving into, which is hyperconnectivity IoT devices, even looking at the 5G mobile communication standards, in which we have a 1 kilometer by 1 kilometer square area, in which we have 1 million devices that can be supported in an area, obviously a cluster tree topology would be very attractive. It may be even necessary, meaning that there's no other way to support all these nodes. Cluster tree topologies are similar to stars, though RFDs are only allowed to connect as the outermost branches to the cluster tree. The diagram shows that the full functional devices connect to the coordinator, which is one of the FFD devices, and this will connect to multiple N devices through that structure. And that is how this network is formed. Looking at some of the general frame formats that are used for IEEE 802.15.4. And because of the function that we were just talking about, having a coordination of multiple clusters connected into a tree format, having a coordinated node in control and management of the network, I just want to show you a couple of components in the frame structure. Over there is a frame control field, which is 2 octets. An octet is a byte, so that means that it's 2 bytes up front, which has a structure like here. It has 16 bits because 1 byte is 1 octet is 8 bits. So 2 octets is 2 bytes, which is 16 bits. That's why the bit number fields are numbered from 0 to 15. Those are your 16 bits. Now, looking at here, I want you to notice that there is a source address and a destination address, but next to them, in orange, you see the source PAN identifier and the destination PAN identifier over there. These are included in. So in other words, it's not only source and destination address, they're also talking about the source and destination PAN address identifiers. So when you do this type of cluster networking in a tree format, your packet may go out of your PAN, go through the cluster tree coordinator to connect to another PAN. In order to do that, not only do you need to know their address, source and destination address, you need to know their source and destination PAN ID, which is what is included right here in orange. Where does my data go? Where does my IPv4 or IPv6 packet go? Where does my TCP IP packet go? That is right here, what you see as frame payload. However, because these are for wireless PAN applications, not all sizes of IPv4 and IPv6 packets can be included. Because, once again, the packet size has a limited structure of the maximum frame has to be less than 127 octets, 127 bytes. That puts a restriction on how large the frame payload can be. The maximum frame header is limited to 25 octets, 25 bytes. In addition, I want you to look at the control frame header, in which what you see is, once again, just 2 octets. Right down here, you will see that security enabled. There's a flag and structure to control that. There's also intra-PAN, you see right there, intra-PAN. And intra-PAN means that this is going to be used for the PAN area, wireless PAN, intra-communication features. You can go outside of your PAN, which is inter-PAN, and then of course you'll need to use your destination and source PAN IDs, as well as the source and destination addresses. That's what you have up here. But if it's internal within your PAN, then of course you flag it using that over there, which has intra-PAN, and then you operate in that type of a mode. So within your PAN, you can use something like a star network, where your centered of the star, which is your full function device, will relay you to another device. Or if it's a P2P, you can directly communicate.